This is work, energy, and power. Work, energy, and power. Question number one. This is first part. Second part will be related to collision problems. So first I'm going to discuss this. This is question number one. A figure shows a smooth track AB. Okay. AB with a rough horizontal surface at B having friction coefficient 0.2. A block of mass 1 kg released on track from a height of 1 meter. Find the distance it will travel on the rough track before coming to the rest. So they are providing this type of track. This is horizontal part here. This is B. This is B here. This is A point, and a block is here. Okay, block is released from here, and this height of the block from the ground, that is how much? That is given as 1 meter. 1 meter. When block will move here, so it will move like this. It is going to move like this. It will move like this, and then it will move on the horizontal surface. This horizontal surface is rough. ठीक है ना? This part is smooth, and this is rough surface. This is rough surface, and they have given us a coefficient of friction mu. So mu is how much? Mu is here. If you look at that, is 0.2. 0.2 in this question. You have to find out how much distance this block is going to move on this rough surface C. So try to understand, when this block will move from A to B, what will be the kinetic energy of this block at point B? So apply conservation of energy. Apply conservation of energy principle of energy, or mechanical energy, you can say. Energy at A and B. A and B. So here kinetic energy will be 0 at point A, plus its height is 1 meter. So this will be mgh. So it will be equal to mass into g into h. H is height, h is 1 meter, that is given. It will be equal to, at point B, ठीक है, kinetic energy is suppose 1 by 2 m v square. This is the kinetic energy at point B, or you can say Vb square, plus here potential energy will be 0. So potential energy is going to be 0, beta. So this will be. So what will be this? This is mgh, or you can say kinetic energy available with this block when block is here. ठीक है, try to understand, when block is reaching at this point, at point B, it is having this much kinetic energy, 1 by 2 mvb square. This is the kinetic energy of the block at point B. And this is how much? This is equal to mgh. Now, due to this kinetic energy, this block will move in the forward direction like this. Its weight is going to act in the downward direction. If you look at its weight, mg, that will act in the downward direction. Normal reaction will be this. This will be the normal reaction. So what will be the normal reaction? That will be equal to mg. In which direction this block will move? It will move in this direction. So a friction force is going to act over it in the opposite direction. So this will be F. ठीक है, this will be kinetic friction because block is moving. So automatically whatever coefficient of friction they are providing us, that is kinetic friction. It is not written in the question. So what will be the friction here? Kinetic friction force. Kinetic friction force will be, ठीक है, कितना होगा बेटा? That will be mu k mg, and this is constant throughout its journey. This fk, this will remain same. So a constant force, opposing force, is acting on this block. So what I say, I am saying that suppose this block travels a distance from here, ठीक है ना, it start a journey from here, and then suppose it travels a distance. Suppose it will move up to this point P. So I'm assuming this displacement of the block with respect to B is x. So at the cost of this kinetic energy, I am assuming this block will reach at the point P, which is at a x distance from B. So how much work is done against this block is doing work against this friction force, because friction force is in the opposite direction. And how it is able to do the work? Because it is having kinetic energy. Because this block is having kinetic energy, so it has the ability to do work against the friction force. But when it is doing work against the friction force, automatically this energy is going to be consumed. So the time at which all the kinetic energy is consumed in doing work, in doing work against friction force, this is the maximum kinetic energy available. And what will be the work done so that this total energy will be consumed? That will be friction force into displacement. Displacement is x. So from here to here, this block is doing work against the friction force, and total energy, total kinetic energy it is having is consumed. So I'm writing here this value of fx is mu k mg. This is the force multiplied by x, distance traveled by it, and 1 by 2 mvv square is equal to mgh. mgh. So mg is going to cancel out here, and x will be h upon mu k. h upon mu k. h is 1 meter divided by zero point 0.2. Okay, so this will be 5 meter. So how much distance it is going to travel? It is going to travel 5 meter before coming to the rest. So this block is going to travel a distance of 5 meter over this rough surface. Okay, na? And at point P, it will lose all of its kinetic energy. Okay, and it will be at rest. So distance traveled will be 5 meter. This is question number 1. This is question number 1. Next, question number 2. Next, beta. Go to question number 2. Can I go to the next?
Yes, sir.
Next question. Question number 2. So here a diagram is given. I have given 2 questions like this they can ask. This is, you are going to find out this is a very famous question related to work and energy. Here you are having a pen. ठीक है ना? You are having a pen and a block is there, and block is here. This is at a height h. ठीक है? This block is at a height h with respect to this pen. ठीक है? This is height h. And what is other things given? H is the height. Okay. A block of mass m initially at rest. So this is its mass is m, and initially it is at rest. It is given. Now they are saying when they drop this mass, okay, then maximum compression in the spring is h by 4. Then maximum compression when it will fall, it will undergo free fall and it will hit this pen, then there will be a compression. So maximum compression will be h by 4. But in this question, what is important? Important is this pen is massless. So first question here, question number 2, I am discussing where this pen is massless. In next question, question number 3, I will discuss the case when this pen is having some mass. So there are 2 different questions. So here, try to understand. Here this pen is massless. So here whatever energy it is having, due to that energy, basically this spring will be compressed. Okay, so what I'm saying suppose this spring will compress by a distance, by a length, you can say x. ठीक है ना? So it is compressed by x. This is the pen here, massless pen. So this. So I'm assuming this compression is x. X, and block will be here. And it is at rest. Now it is at rest. For a moment. Rest for a moment. For a moment. At maximum compression. At maximum compression. Maximum compression. So try to understand initially this was the position. And how much this compression is given, try to understand. They have given us that this is H, and this is H by 4. How much it is? This is H by 4. So how much this X is? This X is H by 4. So at this position, what was the potential energy, extra potential energy? If you look at these two positions. So here at this position, this block is having only potential energy, and how much this potential energy was? mg. With respect to this new position, this will be h plus h by 4. So this will be h plus h by 4. Kinetic energy was 0. Kinetic energy was 0. Now here at this position, I'm assuming it as reference. I'm saying this is reference. Here potential energy is 0. So that's why I'm saying here potential energy is mgh plus h by 4. So at this point, its kinetic energy will be 0. Gravitational potential energy mgh will be 0. Okay? That will be 0. But here spring is compressed because spring is compressed. So due to the compression of the spring, there will be some potential energy here. So this will be 1 by 2 kx square. This will be. This will be 1 by 2 kx square. So this will be the total energy at this point. Initially, this was the energy. Initially, this was the energy. And finally, it will be the energy. So this will be mgh pi by 4. This will be 1 by 2 kx square. This is very good question, important question for exam point of view. This will be here too. So what will be x? This will be 5 mg divided by 2k, and this will be square root. Okay, this will be. So you have to find out this one. Okay. What I have to find out actually here, sorry. So this is okay. Whatever I have done is here is okay. But what they are saying us to calculate, they want the spring constant K, and X is given. So no problem here. I can write here. If they are providing me, value of X, then I can find out K. If they are providing me K, suppose, then I can find out X. So what it will be, so this will be 5 by 2, more simpler, mgh, and this will be K. K is okay, and X is h by 4. So this will be h square by 16. This will be X. This is the compression in the spring. So this will be 2 8 16. So this 1h will cancel out. Okay, so what will be K? This will be 40 mg. This will be 40 mg upon h. So this time this will be answer. So K will be 40 mg upon h. This will be the answer in this question. So from here you can move in both the direction. If they are providing you K, you can find out maximum X. But here this was given. Okay, so because I have already used this, so I should not write like this, but this is the way to solve the problem. They are providing me x. X is h by 4, so h is square by 16. So from here you can find out k. So just by simply applying the conservation of energy, you can solve this question. But this question will become much more improvised. This will be improved. ठीक है ना? Improvisation in this question will take place if you consider the mass of this pen. Suppose you consider this pen is having some mass, then this problem will be a little bit difficult, more complicated. One more step will be there. ठीक है? So please go to next question. Question number 3. Please go through next question. Is this clear to everyone?
Yes, sir.
Now go to the next question. Question number 3. Question number 3. A body of mass m, mass 1 kg falls freely from a height of 100 meter, okay, on a platform of mass 3 kg which is mounted on a spring having a spring constant k equal to this. Body sticks to the platform and spring's maximum compression is found to be x. Given that g is equal to 10 meter per second square, comma, the value of x will be close to, four options were given: 4 centimeter, 8 centimeter, 80 and 40 centimeter. So what is the question here? Question is this. Here this is a spring. With this spring, a pen is attached. This is a pen that is attached with it. And mass of this pen you can say is 3 kg. How much mass is given? That is 3 kg. A block of mass 1 kg here. A block is here. Mass of this block is 1 kg. This is 1 kg mass. This block will fall on it. And this height h, how much is height? 100 meter. So this h is 100 meter. So this is given as 100 meter. Now you have to find out the maximum compression in this spring. How you are going to solve this? Try to understand here. When this mass will fall on this pen, ठीक है, this pen is not massless. So whatever will be the velocity here, whatever will be the momentum here with which it is going to hit the pen, ठीक है, then after that this block will attach with the pen and then pen and block they are going to move in the downward direction. So kinetic energy will become different at this point. In earlier case, because this pen was massless, so we were assuming whatever kinetic energy this block is here having, with the same kinetic energy, with the same energy, this corresponding to that this spring will be compressed. But here situation is changed. Here there will be some kinetic energy with which this block is going to hit here, and then after that block plus pen together they are going to move, so their velocity will be different. ठीक है? So momentum of conservation you have to apply first. But before that I am saying, suppose when this block is going to hit here, try to understand when this block will fall from rest and this block will hit here, what will be the velocity with which it is hitting? I'm saying this is v. I'm saying its velocity is v here. So what will be v? So this will be v square is equal to u square plus 2gh. So v will be equal to u is 0. So this will be square root of 2gs. So 2 into g is 10 and this is 100. So this will be 2000, square root of 2000 meter per second. Now this pen plus, now what will happen? Block plus pen together will move in the downward direction. Together will move in the downward direction. So that's why this is different. Move in the downward direction. In the downward direction. So apply conservation of linear momentum. So together, I'm saying together they are moving with a velocity v. So this will be 1 by 2 m plus m, or not 1 by 2. Sorry. They will move in the downward direction. So mass of the block plus span into velocity, I am assuming they are moving with a velocity v. This will be equal to initial momentum of the block, that is mv. So what will be this v? V will be m is 1 kg. So this will be v upon 1 plus 3 4. So this will be 1 by 4 square root of 2000. So v will be 1 by 4 and square root of 2000. This will be the meter per second with which this block is going to move in the down. Block plus span is going to move in the downward direction. Is it clear up to this point? Hello.
Yes,
Now,
sir.
good. Now apply. Now look here at this point. Now look here at this point. This position is suppose A, and I'm saying this block will move. This span will move, go down with this. Suppose this span will go down by a distance x, or spring will be compressed by x, maximum compression I'm saying. And this position I'm saying this is B. So apply conservation of energy at A and B. So what is the kinetic energy at this point? Kinetic energy at this point will be 1 by 2 m plus m. This will be V square. This will be V square. Okay, this will be the kinetic energy of block plus span. Try to understand here, this block plus span is at a height of x with respect to this position. So what I am assuming, I am saying here potential energy is 0. I'm saying potential energy is 0. So what will be the gravitational potential energy at a height of x? So that will be plus m, and this will be gh or gx, not h. So because here position is x distance in the upward direction, so relative change in potential energy is m plus mgx. So here at this point, it is having kinetic energy plus gravitational potential energy as compared to this position. At this position, at this position, for maximum displacement, velocity will become 0, so kinetic energy will be 0. We are choosing it at reference, so this will be 0 beta. Gravitational potential energy will be 0. But whatever energy was there here, that will convert into the potential energy that will be stored in the spring, because spring is compressed by a distance x. So this will be 1 by 2 kx square. 1 by 2 kx square. This will be, now substitute all these values. So this will be 1 by 2 into 4 into 2000 into 2000. This is v square 2000 upon 16 plus this will be 4 into 10 into x, and this will be 1 by 2. What is k given in this question? What is the value of k? 1.25 into 10 to the power 6. So this will be 1.25 into 10 to the power 6. So this is a very large number. Okay, very large number. So if you bring this large number over here, x will be very small. Remember this. So x will be quite small. So it will be like this. So this will be 4 4 ja 16, 4 5 ja 20, and this will be 250 plus this will be 40x and 1 by 2 into 1.25 into 10 to the power. This will be 6 and into x square. Try to understand one thing here. X is not quite large. ठीक है ना, x is small. ठीक है. So because why x is small? Because f equal to कितना होता है, f equal to minus kx. If k is quite large, for applied force x will be small. Here k is quite large, so x will be small. But here x square is multiplied by this large number. And here this is 250. So if this is small, I can neglect this. Roughly, you can neglect, I'm not saying. And find out this value of x. Approximately you can find out. बताइए कितना आएगा? What will be its value? I can approximate it. 4 options are given. You can check. So for the approximation, I am making it negligible. So this will be 500 on this side. ठीक है. This 2 into 250, this will be 500 divided by, this will be 1.25 into 10 to the power 6. ठीक है. And this will be x square. ठीक है. So this 1.25 4 times here. So if you cut it, this will be 4 times here. So this will be 400. So this will be 4 upon 10 to the power 4 square root of 2, and that will be x. So this will be 2 by 100, and this will be meter. So x will be, you can say this will be 2 centimeter. तो roughly x का वैल्यू कितना होगा? Approximately 2 centimeter. ठीक है ना? So here what was my simple logic here? Because value of k was very large. Value of k is very large, so automatically this number will be very small. This should also be small, but here you have multiplied it by 10 to the power 6, so this will be significant. Here this number will be 250. This is significant, so I neglect this and just simplified this and find out the value of x. So this will be approximated value that they have given in the options. So 2 centimeter. ठीक है, 2 centimeter should be the answer. But here this is given as, this option was not given at that time. This was not a correct question. So 4 options were given and any of the option was not matching. ठीक है ना, with the approximation. What I'm saying, with the approximation, no option was matching, but which was the closest one? This 4, you can say. ठीक है, this 4. So what can you do here? One more thing. If you want to check, ठीक है, this 4 will be there. So multiply here by 4. ठीक है, 4 here and then try to find out. ठीक है, here substitute 4 centimeter, here 4 centimeter, and then you can check. ठीक है, but approximately it is 2 centimeter. Approximately it is 2 centimeter. So I will try to show you this is 250. On the next page, I will show you what I am doing. 250 plus, what is this? This is 40 into, suppose 4 centimeter is the answer. So this will be 40 into 4 into 10 to the power minus 2. ठीक है. So in this way, sometimes you can check. ठीक है, this will be 1 by 2. If you get, you are getting correct answer, then where is the question? This is 1 by 2 equal to 1 by 2 into 1.25 into 10 to the power 6 into x square 4 centimeters. So this will be 16 into 10 to the power minus 4. ठीक है, this will be. So how much it will be? This will be 8 times. ठीक है? This will be 8 times. So 8 5 40 is this will be roughly 10. ठीक है ना? Roughly 10. This will be 10 to the power 2. So on this side you are going to have 1000. ठीक है ना? This will be roughly 1000 here. Uh, so it should be like this. And what is here? 250. ठीक है ना? 250. And this is 160 plus 0.16. कितना हो जाएगा? This will be not 16. This is 4 4 just 16. So 1.60. So you can look here. ठीक है? You can look here that you are not getting this answer even with the help of 4 centimeter you are choosing. So whatever was done here, options which were given in the question, they were not correct. ठीक है ना? They were not correct options. Here, an approximated solution of this question was x equal to 2 centimeter. So whenever you are having this type of difficulty, why I was doing this, that calculation, if whenever you are finding this type of problem, sometimes it may happen in the exam, then you can do the reverse calculation, choose the option that is best matched, and you can substitute here and try to find out. Similarly, you can do the exercise with the other options also. ठीक है? You can try that exercise with other options like 80 centimeter and 40 centimeter and try to find out which one is the correct one. ठीक है? So in this way you can do. But this question at that time, this was not matching with any of the answers. ठीक है? So that was a wrong question. But this is the way to solve this question. This question you are going to find out in many books, but you will find out they have solved this question in terms of M and M in algebraic way. ठीक है? In M and M in algebraic way. What you have to do, only one thing, you have to find out the value of x. So that time it was something went wrong with this question. This is a very standard question in many books, from Resnick Halliday to most of the book in H.C. Verma, in every book you are going to get this question. Next question, beta. Question number, I think this will be 4, na? This was, I think, 3. Okay. This is 4. So that was the way to solve the question. Approximated answer was 2 centimeter. So what I'm saying here, in the earlier case, if you try to understand, if you write here in place of 4 centimeter, if you take 2, ठीक है ना? If you take 2, then this will be 4. It will be less than 4 times. So this will be 250, will match 250. ठीक है? Some students were thinking that I'm not getting answer. Answer 2 centimeter is more or less correct. If you look here, if I do the calculation with whatever answer I get, then this left hand side will be 250 plus this will be here uh, 2. So this will be 80. So this will be 0.80. ठीक है? And on this side, what you are going to have, you will have 1 by 2 into 1.25 into 10 to the power 6 and into this will be 4 into 10 to the power minus 4. So on this side, they are approximately equal. This is 250 if you look, and here this will be 250.80. So if you substitute 2 centimeter, this was a correct answer. So that options were not correct actually. So question 4. Question 4, beta. A block of mass m is kept on a platform which starts from the rest with constant acceleration g by 2 in the upward direction. So this type of diagram is given. This is a platform and here this is a block, and together with they are moving in the upward direction with an acceleration a equal to g by 2. Okay, with this acceleration they are moving up as shown in the figure. Work done by the normal reaction on the block in time t is, in time t, how much work will be done by the normal reaction on the block? You have to find out. So you have to find out in time t how much work will be done by the normal reaction. Okay, on this. So bataiye how you are going to do this. So if you look at this block only, okay. So if you make the free body diagram of this block, on this block, a normal reaction is acting in the upward direction, its weight is acting in the downward direction. And under the influence of these two forces, it is moving up with an acceleration g by 2. So write equation of motion here. What will be? Because this block is moving up, which force will be greater? This normal reaction will be greater. So this is n minus. This will be mg. Okay, this force is causing an acceleration, so this will be mass into acceleration. Acceleration is g by 2. So what will be normal reaction? Normal reaction is 3 by 2 mg. N equal to 3 by 2 mg. This will be. Now, what will be the work done by the normal reaction? So suppose this block this is together, they are moving in the upward direction like this. Suppose distance traveled in time t, okay, from here to here. Suppose block is here, and after time t it is here. Suppose this distance is, you can say s, or whatever you want to say. This is s distance. So how much distance this s will be in time t? In time t, what will be the distance traveled by this? So suppose v is the acceleration is constant. Remember this. This acceleration is constant. So that's why I can use three equation v equal to u plus at. ठीक है, s equal to ut plus 1 by 2 at square, or v square equal to u square plus 2as. So v square, I'm using third equation, v square is equal to u square plus 2as. This v you want to find out. Initially it was at rest 0 plus this will be 2. How much is g? This is g by 2 into s. ठीक है ना? So this will be. Can you use this? No. ठीक है, you are not getting. You want distance. Actually, you want to find out the work done. So you cannot use this. So which equation you are going to use? S equal to ut. That will be first term will be 0 plus, that is okay, 1 by 2. What is a? That is g by 2 into t square. That is okay. So this is the distance traveled in time t. S equal to g by gt square upon 4. This is okay. So what will be the work done here? Work done will be, so here this is the distance traveled by the block in time t. In time t, block is going to travel this distance. Okay. So what will be the work done here? Work done will be F, normal reaction, into displacement. Okay. Normal reaction is 3 by 2 mg, and S will be gt square upon 4. So this will be 3 mg square t square upon 8. ठीक है ना? 3 times mg square t square upon 8. This will be the work done by the normal reaction beta. This will be. ठीक है ना? This will be the work done by the normal reaction. Is it okay with everyone? Question number 4.
Yes,
Yes,
sir.
sir.
Good. Now go to next question. Question number 5. Question number 5. A uniform cable of mass m and length L are placed on a horizontal surface such that its 1 by nth part is hanging below the edge of the surface. To lift the hanging part of the cable up the surface, the work done should be four options are given. Four options are given, beta. Try to solve it. So you are having this type of situation. ठीक है? There is a chain here. This type of chain is there. And 1 by nth part of its length is hanging here like this. And it is L by N. What is the length of it? Length of this hanging part, this is 1 by N. So L by N will be here. Now you have to find out the work done in if you want to place this chain back on the table, what will be the work done? ठीक है ना? You want to find out the work done in lifting the hanging part of the cable. ठीक है ना? Up to the surface. What will be? So this is a very simple question here. So this part is hanging. Where will be its weight is going to act at its center. So basically its center of mass is here. What is this distance? Half of it. This will be L by 2n. And at this point, total mass, what is the mass of it? Mass of it is L by n. ठीक है ना? And mass is given, total mass is given. Total mass is m. So mass per unit length is, this is mass per unit length. This is lambda. What is this? This is mass per unit length. Mass per unit length of this chain. And hanging part length is L by n. ठीक है? So multiply this by lambda. This will be the mass of this part. And multiply it by g. So its weight is going to act in the downward direction. So this mg is acting in the downward direction. Now you want to lift it. You want to lift this chain in the upward and you want to place it on this surface. So what will be the work done? Work done will be equal to the change in potential energy. So here, when you are taking back this, you are lifting this up and you want to place it on the table. ठीक है? What is going to change? Potential energy is going to change. So earlier, center of mass was here. When you will place here, the center of mass will be lifted by a distance L by 2n. So whatever work you are going to do, ठीक है? Whatever work you will do, that work will convert into the potential energy. So work done will be equal to change in potential energy. Here, this is mgh, so this will be lambda by n, and this will lambda by L by n into lambda m. This will be g. And what is this height by which you have lifted it up? This will be L upon 2n. Is it okay?
Yes,
Hello.
sir.
And mass per unit length is okay. ठीक है? So this will be L by n. Lambda is m by L. This will be g here, L by 2n. So 1L will cancel out, and this will be mgl upon 2n square. This will be question number 5. So this will be the work done. Okay, this will be the work done if you want to lift this chain and you want to place it on this table. This will be the answer. mgl upon 2n square. ठीक है. So this will be, please ये जो ऑप्शन बी दिया है, ऑप्शन ए एंड बी आर सेम. ठीक है. Please, whatever I have shared with you, that is option A and B, they are same. So option B may please make a correction. That will be 2 in denominator. This will be 2n square. So option A and B, I have written it as mgl upon n square in option A. If you look into option B, this is mgl upon n square itself. Both are same. Please write here, and this will be the answer. Option B. Option B will be the correct answer. Option B will be the correct answer. So this was next question. Question number 6. Please go through question number 6. This is a very simple question. A cricket ball of mass 0.15 kg is thrown vertically upward by a bowling machine, so that it rises to a maximum height of 20 meter. ठीक है, 20 meter after leaving the machine. So basically this type of bowling machine is there. ठीक है, this type of bowling machine is there. Here there will be some spring or something. I'm not going into that detail. So here you are having a ball like this. ठीक है ना, ball like this. And from here, from this, when it is coming out, then from here to here, this is by 20 meter. It is lifted in the upward direction. It is thrown in the upward direction and it moves up to a maximum height of 20 meter from this point. This is given. This is given after leaving the machine. If the part pushing the ball applies a constant force on the ball and moves horizontally a distance of 0.2 meter while launching the ball. ठीक है? While launching the ball. Then you have to find out. ठीक है, एक कांस्टेंट फोर्स लगता है. दिस इज हॉरिजॉन्टली, सो actually this should be this should not be horizontally, should not be there. So here this part, try to understand, whatever is the pushing part is here. ठीक है, from here a constant force is acting on it, and under the influence of this ball will be here. ठीक है, it will reach here, but from here to here, how much distance it is pushed, how much distance it is pushed, that is 0.2 meter. So 0.2 meter is pushed. So constant force काम कर रहा है. They have already considered whatever it is. ठीक है ना? So they have considered everything here. Or sometimes you can design this. You can think the design of this ball like this also. Of this bowling machine, you can, if you want to consider it exactly horizontally, you can consider the design of this system like this. It is like this. ठीक है? So initially ball was here. ठीक है, you have pushed it with the help of some spring or something, but you are applying a constant force here. Under the influence of this, it shifted to this position. ठीक है ना, it comes to this position, and this is 0.2 meter. 0.2 meter you can also consider in this way, and now it is moving up to a 20 meter. Now from here, it will go up to 20 meters. So you can also consider in this way. You get this type of. So how much work will be done by this force? Work done by the force will be, because this is a constant force, it's not changing. So total work done by it will be F into S. So this will be F into zero point 0.2. This is the work done. Okay, this is the work done. And this work done here, it will convert into the kinetic energy. So its kinetic energy will be this much. So this is the kinetic energy of the ball here. And due to this kinetic energy, this ball will move up and up to a particular height, up to 20 meter. At the highest point, its kinetic energy will become zero, but it will acquire a potential energy mg, and this will be h. So what will be this F? F will be mgh upon zero point 0.2. Okay. Now you can substitute the mass of the ball. How much is 0.15? 0.15 kg is the mass of the ball. G is 10 and height is 20 meter. And this is 0.2. 0.2. Okay. So this will be 30 here, 15 into 2, 30 by 0.2. So this will be 150 Newton. Okay, na? This should be 150 Newton. This constant force should be applied on the ball, and due to this constant force, pushing it by a distance of 0.2 meter, this force is doing a work on it, and this work will convert into kinetic energy here. Now it will move up. It is going to move up. And at what cost it is moving up? Due to this kinetic energy provided by this force. So at this point, it is having this much amount of kinetic energy. This will continuously convert into potential energy, and at the highest point, it will have only potential energy. Kinetic energy will be zero. So this will be F. In this way, you can calculate. Okay, in this way, you can calculate. Is it clear? This was question number 6. So diagram was not given, so you can consider this type of diagram, because they are saying that this ball is pushed in the horizontal direction, and then they are saying it is moving up. So you have to consider this type of diagram. Can I
Sir,
go to next? Yes, beta, please.
sir, zero refers to highest point kinetic energy.
Yes, here it will be at rest. Okay, here V will become zero at the highest point. So kinetic energy will become zero. It will have only potential energy. So that potential energy is mgh. So whatever kinetic energy this ball is going to have here, that is converted into the potential energy. Okay, I have done this. So this is the kinetic energy of the ball actually. Is it clear?
Yes, sir.
Next question. Question number 7. Next question, question number 7. Question number 7. A particle of mass m is projected with velocity u at an angle theta with the horizontal. During the period when the ball descends from the highest point to the position where its velocity vector makes an angle theta by 2 with the horizontal. Find the work done by the gravity force. ठीक है, you have to find out the work done by the gravity force from the highest point to the point where velocity is making an angle theta by 2 with the horizontal. So please look at this question. Suppose this is horizontal surface. First try to understand this question. So here you are having some projectile and you are launching this projectile at a velocity u, and this is theta. So here you can understand that this u can be resolved into two parts. One will be u cos theta, this is horizontal component, and its vertical component will be u sin theta. ठीक है? When this when this projectile will be at the highest point, at this point, what will be the horizontal component of the velocity? You can say here Vy. Vy will be equal to u cos theta. Horizontal component remains same. This will be u cos theta. What will be Vy here? Vx, this is Vx, sorry. Horizontal. What will be Vy? That will be 0. So this is the highest point you can say. At highest point, vertical component will be 0, only horizontal component will be there. And what will be the horizontal component? Horizontal component remain constant throughout the motion. So this will be u cos theta. I'm saying this point is A. What I'm saying this point is A. Now, consider the journey from here, from point A to a point B here. Here, this will be the projectile. This will be its velocity. I'm saying this is V. And here at point B, this is theta by 2. This is given. This will be theta by 2 here. So what it will be? This will be theta by 2 at this point B. So if you write its horizontal component, this will be V cos theta by 2. So what it will be? V cos theta by 2. This will be the horizontal component. Vertically downward component will be V sin theta by 2. Because horizontal component remains constant, so this V cos theta by 2, this V cos theta by 2, this will be equal to this U cos theta, it will be like this, U cos theta. So what is V? V, velocity of the object, of the projectile at point B, will be U cos theta divided by cos theta by 2. This will be the velocity. So I can write here, this will be the velocity. So this is U here and this will be V. So first I find out what is the velocity at this point during this projectile motion. Now you want to find out the work done by the gravitational force. So from here to here. ठीक है, work done by the gravitational force, ठीक है ना, will be change in kinetic energy. If you remember, what will be the work done during this? This will be kf minus ki. In the last class, I have this last to last class. Kf minus ki. What is the kinetic energy at point B? That will be 1 by 2m. This is V square minus 1 by 2m. And at A point, only this u cos theta is there. So this will be Vx square. So this will be 1 by 2 m u square cos square theta upon cos square theta by 2 minus this will be Vx is u cos theta, so this will be 1 by 2 mu square. This is a very good question. They can ask you by providing numbers. I'm solving this in terms of algebraic terms. ठीक है? So this will be u square cos square theta. So take this common. So this will be 1 by 2 m u square cos square theta common. So what will be there? It will be 1 minus cos square theta by 2 divided by this will be cos square theta by 2. So this will be sin square theta by 2 upon cos square theta by 2. So what will be the work done here? Work done will be 1 by 2 mu square cos square theta, and this will be tan square theta by 2. ठीक है, so they will provide you some value like I can give you this is 60 degree, this is 60 degree. ठीक है, so theta by 2 will be 30. So by substituting, mass will be given, initial velocity will be given, and you can find out the work done in this way. So this is a very, very good question for your exam. This was a question. This was question number 7. Now go to question number 8. Next, question number 8. Beta. Question number 8. A block of mass m lying on the smooth horizontal surface is attached to a spring of negligible mass of constant spring constant K. The other end of the spring is fixed as shown in the figure. So what is given in this question, that you are having this type of a block that is attached with a spring. So you are having a block here. This block is here. ठीक है? Here. Mass is given as m and its constant is K. K. The block is initially at rest in its equilibrium position. If now block is pulled with a constant force F, comma, the maximum speed of the block is. So what will be the maximum speed of this block? So what you have done here, you will apply a constant force. This was equilibrium position initially before applying. Now you have applied a constant force. This is continuously applied. So what will be the result of this? So this was initial position, equilibrium position. So due to this force, कितना होगा F? That will be K into x naught. How much it will displace? This will displace this block by x naught. So x naught, the block will be displaced by a distance x naught equal to F by K. So it will be displaced to this position. Now this is new equilibrium position. What you are going to say? This is new equilibrium position. This is x naught. And this is new equilibrium position. New equilibrium position. Now what will happen? Now it will be in equilibrium. If this continuous force is acting continuously, you are not going to change it. But if you displace this block, try to understand, if you displace this block from this equilibrium position, then it will undergo this type of oscillatory motion about this new equilibrium position. Okay, if you displace it by a small distance, then it will undergo this type of oscillation around it. Now, during this oscillation, these are the extreme positions. These are the extreme positions. Clear? At extreme positions, kinetic energy will be 0. Potential energy will be maximum. Potential energy will be 1 by 2 m omega square a square. They will be U max here. And here it will be U max. At this equilibrium position, what will happen at the equilibrium position here? K maximum will be there. Here it will be K max. So at this equilibrium position, you are going to have K max. You want to find out this K max. You want to find out this K max. ठीक है, आपको के मैक्स निकालना है या मैक्सिमम वेलोसिटी निकालना है, देन यू हैव टू सॉल्व दिस नाउ. फर्स्ट, first, when you are bringing this block from here to here, how much work is done by this force? That will be F equal to, sorry, this work done will be, just one second. How much work is done by this? This will be F into x naught. When you are bringing this block, you are shifting this block from here to new equilibrium position by applying a constant force, then work done will be this. Now, work done is this by the force. ठीक है ना, that will provide the maximum kinetic energy here. So I'm writing this will be equal to, due to this work done, this block is going to have maximum kinetic energy V max square. ठीक है, this will be the maximum kinetic energy. But remember this, here when you are displacing this, some of the work done that is converting into kinetic energy. But remember this, when you are stretching this spring, some of the work done will also be stored in the form of potential energy because length of the spring is increased. So that will be how much? That will be 1 by 2 K and x naught square. So this will be the equation. So when you are shifting this block by applying a force F, ठीक है, so at this position, when the block will be at this position, ठीक है ना, it will have maximum kinetic energy. It will have maximum kinetic energy as well as some potential energy will be there because length of the spring is changed. So that will be this. So during this motion, at this point, this maximum kinetic energy will be this. And what will be the potential energy here? Here potential energy will be this 1 by 2 kx square. 1 by 2 k x naught square. ठीक है, k x naught square. At this point, kinetic energy will become zero, and potential energy will be there. So in this way, there will be. So find out. This will be fx naught equal to 1 by 2 m v max square, and this x naught is plus 1 by 2 k f square upon k square. ठीक है ना, k square. So whatever options are given, look into the option. They are providing me answers in f, m, and k. So convert this x naught. This will be f. This will be f upon k. ठीक है, this will be equal to 1 by 2 m v max square plus this will be f square upon 2k. ठीक है, so here this will be f square upon 2k. This is 1, this is half on the other side, and this will be half of mv max square. So 2 will cancel out. This will be f square upon mk, and this will be v max square. So what will be v max? That will be f upon square root of mk. ठीक है, this should be your answer. F upon root of mk. F upon root of mk. This would be your answer, beta. This will be. This is question number 8. This is question number 8 related to work and energy. Now, next question, question number 9. Please note it down. Question number 9, beta. Question number 9. A body of mass m starts moving from rest along the x-axis so that its velocity varies as v equal to a root s. So velocity is given as a function of s, distance, root s, or x you can write it, where a is a constant and s is the distance covered by the body. The total work done by all the forces acting on the body in the first t second. In first t second, what is the work done by all the forces acting on the body? Okay, after the start of the motion. So one thing they are saying u is zero. Initially it was at rest. So what will be the work done? And finally I am saying this velocity after time t. This is the velocity v. Okay. So from here to here, how much time they are taking? That is t. So after t time, velocity is v. So work done will be simply kf minus ki. So kf is 1 by 2 mv square minus 0. So that will be 1 by 2 mv square. That will be work done. ठीक है ना? This will be the work done. 1 by 2 mv square. So you have to find out this in terms of t. ठीक है? If you look into the options, you have to find out the work done in terms of time. So I have to find out this velocity in terms of time. तो मुझे टाइम के टर्म में पता करना है. ओके, सो व्हाट विल बी v? दिस विल बी ds by dt and this will be a root s. I can write it as ds is equal to ds upon root s. I can write like this, and this will be at a dt integrated 0 to t time. At time, this is, I'm assuming it's 0 and this is s. So this will be how much? This will be s to the power minus 1 by 2. Minus 1 by 2. So minus 1 by 2 plus 1, this will be 1 by 2. So this will be root s divided by 1 by 2 on this side, and this will be 80. 80. So this will be, I bring it here. So this will be s will be equal to 1 by 4 a square t square. So this is s as a function of time. So what I find out s as a function of time. So what will be v? V will be ds by dt. As a function of time, this will be 2t. So 1 by 2 a square t. 1 by 2 a square t. So substitute this v here. 1 by 2 m. 1 by 2 a square t and whole square of this. So this will be 4 to the 8. 1 by 8 m a to the power 4 t square. That will be work done. So what will be the work done here? W, that will be 1 by 8 m a to the power 4 t square. ठीक है ना? This is the work done. Question number 9. This was question number 9. Question number 10, beta. Go through question number 10. Next, question number 10. So they have given this type of diagram. Something you can draw in any way. Something like this. So this is horizontal actually. Okay. This type of slope is given. Frictionless. The surface is frictionless here. So you are having a mass, you are having a block here. ठीक है, so I can use another color. You are having a ball here. ठीक है, and now ball or a small disc. This is a disc, beta. This is not a ball. This is a disc here. And what is the height? Height is h. Height is h. This height, this is small h. So a smooth disk A at rest slides down from top of a smooth hill of height h. What should be the height small h of the horizontal portion of the hill so that the disk cover a maximum distance L as shown in the figure. Okay. So what they are showing they have it is slipping in the downward direction like this, and from here, when it will be here, it will have a horizontal velocity. I'm saying this is V. And due to this horizontal motion, because now this disk from here, this disk is moving under the influence of the gravity, so this will be projectile motion. So from here to here, this distance is L. Okay, this is L. So you have to find out maximum value of L, horizontal range. So my first question is, what will be the velocity V here? So this will be very simple. What will be the potential energy at this point? That will be mgh. At this point, here kinetic energy was zero. Here it will have kinetic energy, velocity in the horizontal direction. And second, it is going to have potential energy, small mgh. So here this will be mgh plus half of mv square. mv square. So this will be, m is going to cancel out. So what will be v? V will be 2 times g h minus h, and this will be square root of 2g h minus h. This will be the horizontal velocity here. This will be the horizontal velocity v. Now from here to here, from here to here, ठीक है, I am assuming time t equal to 0 here, and I am saying it is going to hit the ground at time t. To find out this time t, consider the vertical motion. Try to understand what is this. This is only x component. Here this Vy component, that is 0. So you have to find time t when it is going to travel time t in which it is going to travel a vertically downward distance h. So that will be h equal to, this will be Vy, initial Vy, this is Vyt plus 1 by 2 gt square. So this Vy is 0. So what will be the t in which it is going to hit the ground here? That will be 2h upon g, and that will be square root of this. Okay, this will be. So from here to here, it is going to take this time. And how much this horizontal distance, horizontal range will be how much? Horizontal range. Remember this horizontal component of velocity v. This will remain constant. So I will write this v, or you can say it as vx, and this time t. Or you can write it as v into t. Because horizontal component remains constant. So in time t, how much distance it is going to travel? It will travel v is this square root of 2gh minus h. 2h upon g. So this g is going to cancel out. This will be square root of 4 times h minus h. ठीक है? This is range. You want to find out maximum range. So for maximum range, you want to change this h. For maximum range, you can write dr by dh, that will be 0. So this will be how much? If you differentiate this, this will be 1 upon 2 times 4h h minus h. And when you differentiate this term, then this will be 4 times. Here it will be hh, so this will be h. This will be h square, so this will be minus 2h. And this will be equal to 0. If you take this term on this side, so h minus 2h will be 0. So this small h should be equal to h by 2. So what should be the value of small h for the maximum range? That will be h by 2. Okay, so this small h should be h by 2, then this range will be maximum. Now, what will be maximum range? I am writing R max. R max will be equal to square root of 4. H is h by 2. And here this will be h minus h by 2. Okay, so this will be h by 2 and this will also be h by 2. 4 will cancel out. And this R max will be equal to this h. Maximum range may be equal to capital H. Okay, so what can be the maximum range? Maximum range will be capital H if you are placing small h, if this height small h is h by 2. If this is h by 2, then this range will be maximum. What will the maximum value of range? That will be capital H. So it will be like this. So this was another question. This was question number 10. I have given you two more questions. Please solve these questions. They are quite good and first question, particularly 11 question, is very good. Try to solve. In the evening around 9 o'clock, okay, I will take another class in which I will discuss uh, these two questions, and then I will discuss questions of collisions. Okay, questions related to collision. Okay, I am going to discuss in the next class. Okay, beta. Thank you very much.
Thank you, sir.
Welcome, beta.